Okay, so yeah, let's take a look at the Aviatrix software component. So the Aviatrix is a company that was actually born in the cloud for the cloud. Okay, so you will see a lot of vendors, hardware vendors especially, they are trying to do a lift and shift. Basically, they're taking the hardware code running on the router and they're trying to port it into the cloud, right? So that's not a cloud native approach, or that's not how you actually write the code for the cloud, because now you are taking all the complexity, all the baggage with you, and then you're just putting in the cloud. So the software that we build is efficient. It is written for the cloud, and that's the reason you will see, for example, our Aviatrix gateways, you can run them on a T2 micro instance size, which you cannot do for other providers out there providing the cloud platform, for example, Cisco CSR, right? So yeah, so that's the important thing to remember. And also with that architecture, we are providing the operational simplicity. So you know that there are limitations in the cloud. And yeah, these cloud providers, I don't blame them for not providing those operational capabilities, because they are providing these services for thousands and thousands of users. Okay, that's number one. Number two is there, when you look at this momentum was started from the DevOps guys or developers. So they have more services or tools available for the developers, not for the IT architect, networking and security guys. So the first software component in the architecture or in the platform is called the Aviatrix controller. So that's a software that you run in the cloud and you launch it from the marketplace. So it's available in OCI, GCP, Azure, AWS. You go to their marketplace and you launch this instance or a virtual machine. Okay, this is not a SaaS service. This is not a managed service provider type offering we have. This is something for you to keep. This is something you run in your shared VPC or some VPC out there. Okay, and that is very important because initially we had some offerings in the SaaS space, but the enterprises said, you know what, no, this is not going to work for us, because we want to take control of the entire multi-cloud networking and security end-to-end ourselves. We cannot be reliant on someone, and we cannot be dependent on someone, because there are some competitive angles to that as well. Because when you're using a SaaS platform, you are running your services there or applications there, your competitor might be using the same platform there again, right? So yeah, so that's very important to remember. And you only need one controller, right, for to manage all the clouds, the entire multi-cloud networking architecture. You can deploy it in AWS and you can manage all the other cloud, or you can deploy it in Azure and you can deploy all other clouds or manage all other clouds. Okay, this controller is providing the control plane, obviously, but also it is your entry point for the management. So you can manage it through the UI, controller UI. It's a browser-based UI, or you can use Terraform or REST APIs, right? So that is also a very compelling use case for a lot of customers. There is a large customer out in Portland, Oregon, and I was presenting, and then when I told him that you can use this controller for the Terraform as a Terraform entry point, and he was like amazed. He said, "Yeah, this is exactly what I want." Because I have this problem of running or creating those API calls based on the different cloud, and then running the Terraform based on one cloud versus another. Now I have this seamless management plane where I can write one single Terraform code, point it towards your controller, and then you will manage everything in the background for me. So those are the things that are very important. And some more things are like this platform is multi-cloud, multi-account enabled. So you will see a lot of customers or enterprises, they have number of accounts. Some of them, they have one account per VPC, and it's not very easy to manage. Okay, so because let's say if you are just creating a simple peering between two VPCs, now VPC 1 is under account 1, VPC 2 is under account number 2. You initiate the request and then you have to log into account through account number 2 to accept it, or chat someone, hey, can you please accept my VPC peering request? So it's a nightmare, right? So make it all simple for you guys. And then you have this Aviatrix gateway. This is again a software instance or a virtual machine running in the cloud, and you deploy this as needed, right? So in this diagram, I only showed 3, but obviously you will have more based on the number of VPCs or based on the feature that you want to enable in your multi-cloud network architecture. And these gateways are multi-service node. Okay, so you can deploy a gateway for VPN purposes, user VPN, and then you can also enable NAT, for example, or you can deploy it for a transit purposes, and then you can have some other feature turned on to that transit as well, right? So you can have the same gateway code, but based on the service you need, feature you need, we just turn those daemons on these gateways. So with this architecture, with this approach, what we do, we embrace the native constructs. Okay, so wherever we see that this native construct, for example, AWS ELB, right, is doing its job, is there to, they're running as a managed service in the background, is highly available, and then there is no need for us to use our gateways as a load balancer in that space, right? So we embrace all those native constructs, and then we extend. So obviously, I gave you the example of AWS TGW. So we embrace it, but there are some limitations. So we extend through our architecture or by providing some additional features on top. Okay. So yep, and then we also connect to the on-prem infrastructure, and we can talk BGP there. We can receive and exchange routes, and then we can provide additional BGP knobs that you will not get as part of your cloud native BGP implementation, for example. So that's how it's look like. Okay. Yeah, so let's take a look at the core features. What are the features we are enabling, or what are the problems actually we are solving for a lot of customers out there, right? So it's an intelligent control plane, it's an intelligent orchestration plane, multi-cloud enabled controller. And then with that, what you can do, you can create your advanced networking, right? So this transit, this should be the starting point for any multi-cloud networking deployment, that you should really think about the transit really well. And then make sure that you have all the features and capabilities available through this transit. So once you have this transit or a hub, right, in this VNet, then you can attach all these VNets to this transit hub, okay? And then you have this routing enabled, and then you can control who can talk to what, you can enable the policies, you can enforce the traffic routing, you can do traffic engineering, a lot of things. And not only that, this is just one single cloud. You can also extend this architecture to other cloud, for example, AWS. So we will automatically build this peering. Okay, so this is all happening automatically with just single click or just single API call. We will build it, we will manage it, we'll configure both ends, and we'll take care of all the multi account issues and whatnot. And yeah, same thing here, right? So same architecture, you repeat it into different cloud. You are creating basically a multi-cloud networking environment. In this example, it's a GCP, then Oracle, of course. There are some customers who have very specific requirement to run their applications on Oracle platform. So yeah, definitely they are leveraging this product for that. When it comes to providing higher throughput between those locations, could be within the cloud or across multiple clouds, we have something called high performance encryption, which allows you to encrypt the traffic between two endpoints, between our transit, or could be from gateway to gateway at a higher throughput level, going beyond 1.25 GB limitation that you will find in cloud native solutions. And you have the cloud now, there is a requirement to connect the remote branches, physical branches. So we have something called site to cloud, S2C, that will allow you to build the IPSec tunnel or this connectivity over public internet. You can also have this connectivity to on-prem using the dedicated private lease lines through direct connect or through express route, for example. So we do support that. We support the automation and the control for this link as well. The Cloud WAN is a very special case where a lot of customers, they are running their WAN infrastructure using Cisco devices, Cisco routers, and they need a seamless connectivity and a centralized control plane so that they can manage all those branches through a single point, single pane of glass, right? So this is what our controller provides to them. So we manage our side of the tunnel, and we also manage the Cisco router through our controller, the whole life cycle. So all the config changes that you are making, we'll take a note of it. We'll show you the difference of that. We will build a tunnel automatically, all the BGP. You can also issue the Cisco iOS commands, show run, show config, show IP interface or whatever, right? So that's the use case we have. Smart SAML user VPN is extremely popular. We have the SAML code built into our client, right? So it's a native SAML interaction from the user all the way to your destination VPC. We have the integration with Okta, Duo, all those IDP providers, and then enabling two-factor authentication or enhanced security measures, okay? Egress security is very important because your internet is just next to the VPC. So we have the solutions in this space, which I will go over. FireNet is, I don't see any enterprise where they are not using this FireNet. Why? Because layer 7 inspection is a need, right? You cannot run a business without having to have this deep packet inspection firewall inspecting your traffic. In Cloud 1.0, customers used to send their VPC traffic to on-prem, and this is how they get inspected through their on-prem Palo Alto firewall, for example. But now they're realizing that this is not good because this is not the scalable architecture. You're just wasting the bandwidth and you're adding additional latencies. So now what they're doing, they're putting these firewalls into the cloud, right? So we have a solution for that, which allows you to insert the firewall into the traffic flows without those compromises or limitations, like 1.25 GB tunnel limitation or source NAT limitation or visibility issues. So we'll show you that. An operational tool, right? So we talked about this. Seamless operational tool available across multiple clouds through our controller. And also we have extreme visibility product called Copilot that will show you a demo of, and then you will see how we are actually solving those problems for those enterprise customers. So now I'm going to show you the UI of our controller. So we'll show you an inventory of what's currently running in your multi-cloud architecture. So number of AWS account, Azure account, Spoke, and then if there is a problem, we'll show you, okay, there is something going on with the side to cloud. There are some issues, right? So we'll show you that. We'll also show you this nice map that will show you how things are actually connected in the background between different gateways and TGWs and whatnot. In the bottom, we'll show you some gateway metrics. So you can see a lot of information that we provide here, which obviously you cannot see from the cloud native tools or the cloud native instances. So we just give you in one shot, okay? The metrics from the controller, FQDN stats, the top talkers, top blockers, user VPN, how many people logged in last 24 hours and whatnot, right? So this is how the controller dashboard looks like. Onboarding the users are extremely important, and it's very simple. So you select the cloud, and then you just specify the credentials here, and that's how you actually connect. So what you see here is actually, I can go on and on and on, but the important thing to remember that all these features, all this functionality is actually use case driven. It's workflow based. So we make it extremely simple for you to consume it. So you just follow step 1, 2, 3, 4, 5, 6, and then you're done. You have this use case running in your cloud. So for example, this is the Aviatrix Transit network use case, or when you're deploying the Aviatrix Transit, and this should be your first step after you onboard the controller or you log into the controller, that you launch the VPC, Transit VPC gateway in AWS, and then you enable HA. And then if you want to connect this gateway to some external devices using VGW, or could be over Direct Connect, for example, that's the step that you take, and then you specify the BGP, and then you launch your Spoke. And if you're not really sure about, okay, what does it mean, right? So you can click on this link here. This is context aware help that you have that will take you directly to the page related to that feature or that option on the page. And then you can see, okay, oh, okay, that's the VPC ID I need to look at, or, oh, yeah, I need to enable SNAT and whatnot, right? Yeah, so that's the context aware help we have as part of the product. And all these options are here. The FireNet, the Cloud WAN, if you just want to do peering between two devices, site to cloud, when you want to connect to the on-prem resources. In security, we have a stateful firewall, egress control, public subnet control, private SDN, a lot of features. You VPC tools, you can create the VPC directly from here, or if you have your own scripts, CloudFormation or Terraform, that's fine. We can consume it directly from the controller. You have a lot of options in the settings, advanced logging, you have different logging options. And then we have in troubleshooting, a lot of options for you to play with or utilize to solve your business challenges, okay? So I'm gonna stop this here now and go back to my, all right. So you saw a lot of capabilities, a lot of features. So, you know, I'm just making it very simple for you guys because I know there are questions in the test. So just remember that we have categorized all these features and functionalities into 4 big buckets. The most important thing is transit, number 1. Then security. There are lots of security features and options. Automation is just built into the product. There are so many things we do automatically for you that you don't even see, but those are the things happening. And then we provide you the REST API, complete REST API for anything that you saw, and then Terraform, and then the operational simplicity, okay? So let's talk about the transit networking. So we know now that when it comes to VPCs or VNet talking to each other, the cloud native option mainly is to create native VPC or VNet peering, okay? But we also know that this is not scalable. This is not enterprise grade. You need to create full mesh. It's unmanageable, basically, okay? There is no network correctness, right? And then troubleshooting and management is extremely complex because you don't know, you cannot log in, you cannot do, packet capture, for example. So yeah, so this is what we know. We already learned that. Now, if you look at these cloud providers, they are trying their best to provide you some transit options or transit routing options. So AWS, they came up with the AWS Transit Gateway, or TGW as we call it. In 2018 November, AWS has been there for so long, but it's not easy to come up with the transit solution because it's a serious business, okay? And even though they have this AWS TGW, but it is, there are visibility issues there, right? You cannot peer within region, for example, just, one limitation. It's just a flat architecture. When you connect those VPCs, they're just, wide open, talking to each other. You have to manually delete routes or do things of that nature. And then the BGP support is obviously limited. Okay, so that's what they have. In Azure, you learned about different transit solution options, and they have their limitations. And yeah, this is what they have, right? So in GCP, there is no native option available. So they promote use of single VPC because for them it's just a global VPC, it's global routing. But we know as an IT architect that sometimes businesses they need those boundaries, those segregations, those security controls in place, right? And same is true for OCI. They don't have any native solution yet, and that's why they're promoting third-party appliance-based transit. Okay, so that's the cloud native thing, right? Now let's talk about the non-Aviatrix third-party transit solutions. For example, Cisco CSR. Okay, yeah, it's the same problem there because now it's just an individual device. You log in, you SSH, you configure, you manage the IPSec configuration, and it is error prone. Okay, and when it comes to the throughput, it cannot provide the throughput that your enterprise demand, basically, because now you're building the IPSec tunnel and you're back to square one where Oh my God, it's 1.25 GB per tunnel. So okay, so yeah, so those are the things. And then the ECMP, you think about ECMP, yeah, ECMP is not supported on the native constructs, for example, VGW. You end up managing this entire BGP, so you become the service provider basically. So you don't want to be in the business of doing that. Keep doing that, right? The reason you're moving to cloud to make your life simple, not like extra difficult. Yeah. So those are the problems with those third-party solutions. Now let's look at this Aviatrix transit architecture. So when we built this architecture, we didn't just build the product. We thought through. We said, okay, how do you actually architect things in real life or for your network, right? So just even you're building a house, I mean, it's just a basic thing, right? You make sure that you're building it close to good schools, for example, if you have family, right? And then you make sure that it's not in the flood zone, it's not close to the high tension wires or 5G towers and whatnot. Because when you build something, the foundation has to be very strong, because you're building it for long term, not for the short term, right? So you have to come up with a well-rounded architecture. It should have a robust connectivity, it should scale out, and also repeatable, because you do things in AWS in one single region, you want to do the same thing in the other region. You don't want to reinvent the wheel. And then when you go to Azure, you want to do the same thing, right? It's the same thing you did in the on-prem. You had this pod that you took, and then you replicate it to other places in the same data center or even across data centers. You need to have the end-to-end network awareness. You need to know what's going on into your network. It should give you proper alerts. It should correct the network automatically for you. You should have some service chaining options, so you can insert third-party services. It could be just another third-party load balancer or a WAN optimizer or next-generation firewall. You must have complete visibility into the operations, because building something is a day one job, but day two is not just day two. Day two is forever, basically, right? So you keep managing it, growing it, troubleshooting it forever, basically. So that's why we have this architecture. The transit is extremely important. All this transaction and then deployment is controlled through the controller that you see on the left hand side. And you can see this is nicely in line with the MCN architecture. So you have these layers. Now you know, your mind is working. You're saying, okay, yeah, I know where I need to put this transit VPC. It must go here in this layer, right? So you deploy it. You deploy the transit gateways through the controller, and then you have this application layer where you have your spoke VPCs, and then you deploy these Aviatrix gateway there, and then you connect them, okay? And then you take it and then repeat it in Azure, same thing, right? And then you build this tunnel, the transit peering between the cloud. Again, this is directly through the controller, automatically done for you. And then let's say if you have this need to tap into some machine learning application in GCP, yeah, then you have the same architecture. It's no big deal, right? So your boss comes to you and say, I need to now extend this architecture in GCP, or I have this application, I need connectivity there. Okay, I do it, yesterday. So yeah, so now you have already the answer. Okay. Yep. So now we are building all these tunnels for you, the full connectivity between these transits, and yeah, so that's how you actually build the transit network. There is one important feature that I want to highlight. There are lots of features, but this one I think is important. And if you go to this community.aviatrix.com website, just search for BGP, and you will see lots of traffic engineering options on our website. There's an article that we have posted there that will talk to you or teach you about all those options. But yeah, this is important. So what is happening here is that a lot of customers, they come to us and they said that when it comes to connecting the on-prem to the transit, there are cases when they cannot really trust the partners that is coming into the transit. And what happened that a lot of time they configured or misconfigured route on the on-site, it came into transit, and then it went to the spokes and other places, and it destroyed their routing scheme basically. So we added this feature called BGP Route Approval. So what happens that when you receive a route from on-prem, we will not propagate this route to other places, to other spokes. As the admin will get an email saying, hey, I'm receiving this new route. Do you trust this? So if you trust this route, then you log into the controller and then you approve. And once you approve, then it will go to the other places. So that is just one example that I wanted to highlight that shows you that why your transit is very important and all those features, because obviously you will not get this from the cloud native solutions or even third-party transit options there. Okay, so this is about the transit. Now we are moving into HPE, high performance encryption. All right, so let's take this example. What you see here on this screen is an enterprise deployment. On top, you see the cloud, public cloud, and your applications, Aviatrix, Datapath, encryption. And by default, you know this is, they don't encrypt, okay? These cloud providers, they don't encrypt the traffic in motion. Data at rest, yes, they do, but when it comes to the traffic that is moving in, yeah, it's not encrypted. So what they ask you to do, like I said in the beginning, it's a shared responsibility. So they will ask you that, hey, you need to encrypt your application, okay? IPSec, TLS, and whatnot. Okay, so now some developers are encrypting, some of them are not encrypting, right? So you don't really know. Okay, so that's it. That's what is happening in the cloud. Now let's talk about this data center. Yeah, this is your data center. You trust everything and you encrypt everything, you control everything. So things are good here. Now you need to connect this data center to your cloud. You go to Equinix or CenturyLink, you say, hey, I need this link, this private dedicated link should be 10 gig, so I can connect. And in AWS, it could be Direct Connect or Express Route. So this portion is not encrypted, okay? So this is not in your control. This is some third party. This is not encrypted. So what are the choices to encrypt this? Because as an IT architect, this is your responsibility to make sure that you are in compliance. Your audit should not fail. So what you do, you basically build IPSec tunnel. But we know that when you build a regular IPSec tunnel, it's limited by 1.25 GB. So you purchase 10 gig, you're paying for 10 gig, but you're only getting 1.25 GB. So how do you solve this problem? And before we solve it, why is it actually 1.25 GB, right? So the reason is that the way these virtual machines are being written or the code is being deployed, when they build the IPSec tunnel, they only use single core to build this IPSec tunnel. And this is where the problem is coming in. And this is a problem across the board. It's a problem when you talk to different instances between VPCs or from on-prem to cloud, or even one cloud to another cloud. It's the same problem. So the way we solve it, when we build the tunnel using our HPE technology, you can also see it on docs.aviatrix.com as insane mode encryption. Okay, so yeah, so when we build it, we use all the CPU cores and we build multiple tunnels based on the gateway instance size. So we can build 8 tunnels, we can build 16, 32, 64, so we can go all the way up at the line rate basically. So you will see in our transit can support all the way up to 70 gig throughput, which is a lot, right? So that's how we actually solving this challenge or problem. So how does it look like in the MCN architecture? So you have the transit, you have a spoke VPCs, and then you enable HPE here. So you can see we can go all the way up to 70 gig. When you're connecting this transit to your direct connect location or on-prem data center, we can go line rate. If you have purchased 10 gig, we can go 10 gig, not a problem. All encrypted. Yeah, this is in VNet in Azure. Same story, no problem at all. And when you're connecting these clouds together, you enable insane mode and you get the line rate performance, whatever they throttle here. Okay, so because you should know that when you are sending this traffic over the internet, they actually do throttle. So in some cases, it's 5G only, right? So yeah, so whatever they have, we will support it at the line rate. And to be honest, we actually go beyond what they support. And the reason is that when you are building these tunnels between our gateways, we have something called active mesh. So active mesh builds multiple tunnels. So it's a crisscross type data center connection where you have, line going here and then there. And then from the second gateway going to the gateway on top and then gateway at the bottom. So basically there are 4 tunnels. So you can do the math. Okay, so yeah, and all encrypted by default. This transit is encrypted by default. You don't have to do anything to enable encryption. So, okay, so that's HPE, high performance encryption. Now let's talk about the egress filtering. This is about sending the traffic towards the internet from the VPCs. Okay, so why do we need to send traffic out in the first place? The reality is that these workloads, they do require access to public locations, for example, GitHub, or to download some patches from internet, right? So this is it's a requirement. But and we know that this is not secure, it's highly risky. So you need to secure it. So how do you actually secure it? The option number 1 is to use a NAT gateway from the cloud provider, right? So, but the limitation is that the NAT gateway is going to provide you security mechanisms based on IP rules. So you can write access control lists based on source, destination IP, port, and protocol. That's it. It won't allow you to write the rules based on the fully qualified domain names or based on the websites that you're trying to reach. And this is when you will need this feature from Aviatrix to allow you to do so, right? So this is all centrally managed by the controller. So you create the policies in the controller and they're pushed to the gateways, respective gateways in respective VPCs automatically. You can create the zero trust policy if you want. So, everything is blocked and you allow whatever you want to allow. You can also have option to pick a certain subnet and you say all the instances sitting in that subnets can go out, but not the other, for example. Right? We can do the filtering based on TCP, UDP, HTTP, HTTPS, a lot of options there. Okay. We do support wildcard, which is very important because, for example, this Office 365, they have the IP addresses in the back. So let's say if you're not using our solution, you're using a NAT gateway, you created the rules using those IP addresses. Those are published by Microsoft, obviously. But they keep changing it in the background. So are you going to keep up with that all the time? Are you going to go back every now and then and add those IPs or remove those old IPs? No, that's not humanly possible, right? So that's why we support wildcards. So you can say that star.github.com allowed, for example, or blocked. We do support this feature on public subnet and private subnet. And this is a notion that you find in AWS only, where when you create a subnet, you can specify it or designate a subnet as a public subnet by pointing this subnet towards the IGW, right? So we do support that. Both options are supported. If your instances are completely on the private subnet, yeah, definitely this is going to work as well. Obviously, we support NAT because we are replacing the NAT gateway here. Cool. So this is how the deployment models will look like. So on the right-hand side is the most popular deployment model where you have the VPCs, you have the instances there, and then you deploy our gateway inside the VPC. And that's how you can actually filter the traffic going out towards the internet, supported in all cloud. And then on the left-hand side is a special case where some customers, they would like to send all the traffic to a security VPC or internet VPC, and then they want to send traffic out towards the internet. So we support both centralized egress or distributed egress models. Okay, so we talked about the egress security. Now what about the traffic that is coming in from the internet? How we are actually solving those business problems. Okay, so when it comes to ingress traffic and then providing the security, these cloud providers, they have their own solutions. For example, in AWS, you will find guard duty, which will tell you that this is a malicious IP address. Someone or some bad actor sitting on the internet is trying to send this data to you. You should take a look at it and block this, right? So they will actually just tell you, they will not enforce you. So they will just detect, it will not be enforced, right? It does not take any action on that. So yeah, so you saw that, you saw this alert coming in, then what else? I mean, are you gonna go back into the gateway or NAT gateway and add this rule there? Again, it's not humanly possible. All right, so what we do, basically we allow those findings to be enforced. So when we see those IP addresses, those bad actors, we will automatically enforce and create a rule inside the gateway to block that traffic from coming in, right? So this is exactly what you see here. The guard duty is running here. The traffic is coming in from outside. So the controller is actually constantly getting these reports. It can get it from runtime as well. And then based on the report, we can automatically program these gateways and block the traffic from coming in from outside.